Welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Today I will show you multiple methods to solve the problem. Rearranging fruits. You have two fruit baskets. Both of them contains n fruits each, and there are two basket integer arrays. Okay, so that represents the cost of the fruit in each basket. You want to make both the baskets equal. So what does it means? It means that both of the if you sort those both of the arrays of the baskets, you should get the same array. Okay, you should get the same array. So to do so, you can do the following operation as many number of times as you want. You can choose two indices, swap the ith fruit of basket 1 with the jth fruit of basket 2, and the cost of this swap is minimum of these two, and two baskets are considered equal if sorting them according to the fruit cost makes them exactly the same baskets. So I already it already told you this what does equal basket means, and you need to return the minimum possible cost of making both the basket which is equal to both the basket equal, or you need to return -1 when it is impossible. So if you try to see in this example, 4,222 and 1,412. Okay, so if you have something like 4,222 and 1,412. So what does the problem say exactly? If you swap this element with this element, okay, if you are swapping these two elements, what are the array elements which you will get? You will get something like this, and you will get also something like 2,412. Okay, you will get both of this, and if you sort them, if you sort these values, what will you get? 1, 2, 2, 4. And if you sort this, again you will get 1, 2, 2, 4. So these are the same arrays which you are exactly getting. Okay, and how many operations did you perform? You perform exactly one swap. Okay, so the operations performed is, so what is the cost of this operation? Minimum of these 2 and 1, so which is 1. Okay, so cost to make both the array equal, the cost incurred is this one, and this is what are the cases. So if you notice that it is already told that both of the fruit basket consists of n fruits each. Okay, so you do not need to bother about the number of fruits in each basket. They will be always n, and you need to also bother that what exactly do you need to think is that you have two baskets. Okay, what if, let's say, a fruit which is 6. Okay, the cost of the fruit which is 6, let's say this is 2 times here, and let's say this is 3 times here, total 5 times it is present. How can you possibly divide them equally? Okay, you cannot possibly do it. Okay, so to get the final, to get the to finally get both of the arrays same, you need to have each fruit an even number of times. Okay, this is your first observation, which is very straightforward. So what you can simply do is that first make a frequency map of, let's say you have two baskets, and let's say first is basket 1. You make a frequency map of basket 1 where the frequency value will be something like cost comma frequency. Okay, so cost of one particular fruit, and what is the frequency of that, frequency of occurrence of that. So uh, I hope you get it. I hope you get it. And you will also make another frequency map, F2, and that will also consist of basket comma frequency. What you can do is that you can iterate through these maps, and if you see something like the cost, the frequencies, the sum of the two frequencies. So let's say this has two count of two number of 6, two number of sixes, and this is three number of sixes. So you can iterate through all the elements and see that if the sum of frequency is here, what is 2 plus 3, which is 5. If it is odd, if this is odd, then you can directly return -1, right? You can directly return -1 because you cannot make both the baskets equal, whatever be the case, however hard you try, you cannot make the both of these baskets equal. So this is the first thing which you need to do. Okay, now how will you exactly redistribute among the baskets? So so let's consider a possible redistribution. Let's say basket 1 consists of a particular number of fruits 5 times, Okay, so let's say 5 times it has something like 4. Okay, in the whole array somewhere in the middle it has 5 times 4, and this b2 has only one time that particular fruit. Okay, so let's say this 4 is having only one time. Okay, so what is the sum of these two? These are 6 times. So they are redistributable, definitely. How they are redistributable? You can redistribute both of them to have 3 plus 3. Okay, 6 can be written as 3 plus 3, and therefore 3 fruit in basket 1 and 3 fruit in basket 2. This particular kind of fruit only I am talking about. I am going through only one particular kind of fruit. Okay, so how will you know that how many fruits you exactly require? So you see, how many extra fruits are there in basket 1? Basket 1 is having 5 minus 1 equal to 4 number of extra fruits. Okay, out of these extra fruits, how many do you need to redistribute? How many do you need to change the location? So 4 by 2. Okay, so extra, you can say that extra by 2, whatever will be the extra, that by 2 number of times, this is we need to change the location. Change location, or we need to swap. Okay, so you need to swap two of the fours from basket 1 to basket 2. Okay, then you will get three fours in both the baskets. Okay, and I hope you understood this. Now this is applicable for all of the this is definitely applicable for all of the kinds of fruits. Okay, so you do iterate among all the elements in basket 1 and basket 2. Okay, so iterate through all elements. Okay, and perform the same thing, all elements, and perform the same thing as I told you. And what you do, you need to make a vector. Let's say I make a vector which will store the fruits which needs to change its location. So let's say vector, I initialize a vector by this. I will push back both of these elements in the vector. So let's say the vector will contain something like 4 4, let's say 8 8 8. Okay, and let's say 10, something like this. You can sort this vector also. So what does this vector say? It says that you need to change the location of these fruits, no matter in which basket they are. You need to change the location of these fruits. Now the thing which you can do is that definitely you can swap this 4. You can swap this 4 with this 10. Okay, so what do I mean by this? Let's say this 10. What do I mean by this? Okay, so let's say this 4 and this 10 are present in, let's say you need to redistribute them, right? You need to redistribute them. So you can swap them. Okay, so let's say this basket 1 has some 4 here. This basket 2 has some 10 here. You can swap both of them. You can swap both of them to get 10 and 4. So you got to change the location of both of them. You got to change the location of both of them very easily. And what you can do now is that the least element you can swap with the highest element, and in a similar manner the second last element you can swap with the third last element. And in this manner, what you can do is that you can swap all the elements. You can simply swap all the elements, and you have what are the cost? What is the cost? 4 plus 4 plus 4 8. So this is the minimum cost can do. So let's try to implement this first. And then we will try to analyze what is the mistake in this approach and why is it exactly wrong. So let's try to understand this. You cannot tell me something like, what if this 4 and 10 are 4 10 8 8, everything is present in the same map, then with what we will exchange? So if that is happening, you see, that cannot happen because every element should have something corresponding to which it can swap. Okay, and you always need the least of them to swap. So because both of the array are of equal length, like if you consider something that all of these are in the same array only, and what exactly do you, what then my question is that what will you swap them with? What exactly will you swap them with? You have nothing with exactly which you will swap with. Okay, so I hope you get it easily. And let's try to implement this first. So at first, as I told you, I will create two frequency maps. Okay, so let's make two maps. Okay, one will have the frequency 1 and frequency 2. What I can do is very simple. I can go through all the elements in basket 1 and I can just push them in this map. Okay, I can just push them in this map. So let me just not write, not try to write everything in one line. I will just do this thing. And let's say uh, we have something like this also. F2 is, we can go through basket 2 also and update the frequency of 2. Okay. Now, what you can do is that you can write a calc function. Okay. So let me write some function calc which will take two map values. So at first you can traverse through this for, let's say, I can traverse through this. I hope you know how to traverse through a map. You can key comma value pair of this first element. Okay, F1 I can just traverse through. And what I can tell that if the frequency of this F1, okay, if the frequency of this F1 plus the frequency of this F2 of that particular element, which is in F1, okay, if the frequency is something like modulo 2 1, if it is odd, then you can simply return -1 because I don't need to do anything else. Also, if these two elements are not equal, if they are equal, see, if f1, if the frequency of both of them are equal, I do not need to redistribute at all. Okay, so there is a possibility that they are not equal. So what can I do in that case? I can have something like I want to ask myself that how many extra elements are there. So what is the count of those extra elements? So that will be, I don't know which one is greater, so I will make absolute value of f1 minus f2. Okay, so what you can do now, these are the extra elements. So in this you see the extra elements were 4. Now 4 by 2, extra by 2 number of elements, you need to change location. Okay, so you can have a global vector which will tell me that how many which elements need to change location. Okay, so which elements need to change location, this vector will tell me. And while you can do, first of all, this is extra, right? So I can just extra by 2 because these many elements need to change location. And while kind count minus minus, I can just do vector dot pushback. I can just push all the elements. Okay, so I hope you get it easily. I hope this is very much understandable. I am building the vector which contains of elements which needs to change the location. Okay, so that's all. That's all. And at end, let's return it 1. Okay, let's return a 1 just like that because it is integer and it needs to return something at least. So first I will go through all the elements of f1 and also I will go through all the elements of f2. But if you see when it will go through the elements of f1 in there, it will encounter this 4 and it will do the same thing like f1 of 4 plus f2 of 4. uh, that will be, if it is odd, and then it will return -1 or something like that. And if it is even, it will try to redistribute them, it will try to. But you see, if I have done for the element 4, I do not need to do again for the element 4 when I am iterating through the other basket. Okay, because there will be repetitions otherwise. Okay, so we need to get rid of those repetitions. I will just have a scene map. Okay, so I will take care that I do not repeat anything. So I will have a scene map. What will I do in this? I will say that if you have seen or visited this value earlier, then simply continue. You can simply continue it. Okay. Otherwise, you can do this scene equal to 1. Okay. Scene equal to 1. So I hope you get it. I hope you get it. If scene is there, I mean, if you have already seen the element, don't need to check again whether the frequency of that element from the other map you take and add and do again, try to redistribute. If once you have done, that is sufficient. Otherwise there might be repetitions which I want to just avoid it. Okay, which I just want to avoid. And you see, now what we will do at first, we will this only iterates through f1, right? But we need to iterate through both of the maps. So I will just pass this calc function something like if calc of f1 f2 is equal to -1, you can just simply return -1, right? Again, so it will call the function in this manner, and it will again calculate everything inside it also. Then I will also swap these values. By swapping, what do I get? That instead of f1, I am getting f2. So in the next place, I will just iterate through f2 instead of f1, and my that criteria will also get satisfied, and I will just simply return -1 also here. So I hope you get it. I hope you get it easily. And let me store some answer. Let it be long, because I have already done hash defined long ll. And what I can do, as I told you here, what I can do, I can swap the minimum element with the maximum element in both of the arrays, and my cost will be of the minimum element. So my cost will be in the first half of the array only. So my cost will be of the first half of the array. So if you try to think something like this and go to iterate this vector dot size by 2 I plus plus. Okay, so and what you can do is that answer plus equal to vector of I. uh, this is the minimum element. So at first you need to sort the vector also. Okay, so to make sure that the minimum elements always appear at the front. And so you do something like vector dot begin, vector dot end, and yeah, and this, and you need to return this answer. Okay, do you think we did everything correct? Do you think we did everything correct, or is there a mistake? Let's try to check. So you see, in one case, this was not exactly in the test case, this was in the runtime case. Okay, so I just took it to make you understand. This example is a very interesting example, and this is given here. So you see, uh, what are the array elements which you need from these? What are the array elements which you need? So you need, let's say this 80. Okay, this 80 is having two times, but there it is no times. So you need to redistribute 80. Okay. Now what is there? 84 is there two times. Okay. Now 43 is there two times. You need to redistribute that also. So I am directly picking up the element which I need to redistribute. Okay. You do not need to redistribute 8 because it is present. 88 you do need to redistribute. Okay. So 88 you do need to redistribute. You got 14, which you do not need because 14 is present here, and 100 also you do not need because the 100 is present here. And for this, you have 42, which you need to redistribute. Okay, you have 42. You also have 32, which you need to redistribute. You also have 68, which you need to redistribute. 84, do you need 84 to redistribute? So 84 is present here, you do not need, and 8 is also. So these are the elements which you need to redistribute. And my answer is saying something else. My answer is saying that you can always do it in 48 cost. Now you can think that if I try to do something like swap this 32 with 88, okay, I can swap this 32 with 88, and I will get the minimum cost to be 32. And if I take any other elements, it will go much more than 48. But you see, there is an element 8 which is present here. That element 8 also you can use to swap two times. Okay, so what you can do, what is the largest thing? 88, right? So what you can do, you can swap this with 88. Okay, so now this element will have 88 here, and this will have an 8. Now 8 is present two times. Now what is the second largest element which you need to swap it with? Okay, you need to swap it with 80. Okay, you can do that afterwards. You can do that afterwards. As of now, you can swap with something in this array. Okay, some largest value in this array. So 68 is the largest value in this array which you need to swap with. So you again swap with 8 and 68. Okay, so what do you get? 68 comes here and 8 again goes there. So you see, in the whole, both of this operation, what is your cost? You swapped 88 and 8. Okay, so cost is 8. You swapped 68 and 8. Your cost is again 8. So you see, your total cost was only 16 in whole of this, and you managed to swap these two large numbers, 88 and 68. So the thing is that here you need to understand something, is that you have two choices, whether you can swap the elements directly, or you can use the minimum element in global minima of both of the array. You can use the global minima of both of the array to swap Okay, to swap you have two choices. Then you will ask me that when is the time that I need to use this minimum element? When is exactly the time which when I need to use this element to swap? So then I will tell you that uh, you are, let's say, swapping 8 with another array, then it will cause a disbalance of 8 also. Okay, so you need to swap two times. If it has a proper, I mean, if it is present in a proper manner, then you need to swap two times, right? So whenever you are iterating through this element, you are iterating through the array. Okay, when you are iterating through the array which needs to be swapped, okay, you also take an account where the element which I am going to swap is that equal to 2 into the minimum element. Okay, because with this, by spending this amount, I can swap two elements. By spending this much amount of minimum cost, I can swap two elements. So you need to check whether that is minimum. So let's say something like 6 is also there. You will definitely not use 8 to swap that 6. Okay, you will also not use something like, even if you get something like 10, or even if you get something like 15, you will not use that to swap 8. You will not use 8 to swap that, because you 8 you need to swap two times. Okay, you need to swap two times to make it, I mean, to make it something, uh, to make it appear at the same place again. Okay, so you need to swap something which is greater than or equal greater than 16. Okay, if you get some value greater than 16, then only you can use 8 to swap. Oh, I hope you get it. Okay, you try to understand this clearly. Okay, as I will code, this will be more clear. So what I was missing is the minimum value. You calculate a global minima. Okay, so you just calculate a global minima. I will just do it. So let's say minimum is something like mn and this x. Okay, and this minimum value is nothing but this mn and x. You got a global minima. This is your tool which you can swap. Okay, now you make an account of how many elements you are swapping. Okay, how many elements you are swapping. Now if you get something like if vector of I is less than or equal to 2 into minimum, okay, then you can swap them. Swap plus equal to 2, and swap two elements. Okay, and what will be the cost of that? What will be the cost of that? Cost of that will be nothing but this vector of I. Okay, the cost of that will be this vector of I. Otherwise you can use the minimum element to swap. Okay, so how many elements remain that need to be swapped? So answer plus equal to, you can do something like how many elements remain. Total number of elements, what are the total number of elements that need to be resized, which is relocated, which is vector dot size minus swap. These many elements are still remaining to be swapped. All of them can be efficiently swapped using the minimum array by changing the positions of the minimum array. So these many elements you can swap by using this minimum. Okay, and you just do a typecast of long here also, because this might be a long value. And now if you try to run it, I guess it should run fine. What do you think? It is running fine. Let's try to submit it and check if it works. Or can we do something to make it more efficient? So you see, we have passed all the test cases, but the runtime and memory complexity are really poor. So definitely we need to try to do something. Okay, try to do something if it is possible. Okay, so you try to pause the video and think what efficiency can we use? What major efficiency boost can we use? Do you think we need these maps, both of these maps? I'm asking you this question. Take this hint and pause the video and try to think. So so now, after you have thought, I will try to tell you one intuition is that you need the difference of these elements. Always you need the difference of these elements. So you can do a map. What if you can do a single map, use a single map? You increment all the first, always in the first map. Second map, you can decrement those values. So what I am doing here exactly? So earlier I was doing subtraction, but uh, you see 5 minus 1, you see 4 I am encountering 5 times. Okay, in the frequency map, I had something like 4 5 times, And when I'm going through this basket, I got another 4, okay, one time, and I just decremented that 4 to 5. So it is directly storing the extra elements which we needed earlier. Okay. And if it does not have, if you tell me something like it has some element, let's say 6, basket 1 is having 0 times, basket 2 is having 2 times, then it will be minus 2, right? This 6 corresponding to this 6, this will be minus 2 because we have decremented the 6. Okay, so I hope you get this. That's not a problem. We can always take the absolute value of it. So you see, we can store it in this manner also. The thing is that, and we can try to optimize it. We can definitely try to optimize it. What I can do is that I can keep a single loop. I can keep a single loop which will go through all the elements of this frequency. Okay, so uh, this is the way how we iterate through a map. So I am iterating through this map. Okay, now what are the things which I need to do? I do not need to do, since this is a single map only, I do not need to have this scene map at all. Okay, so I'm getting rid of one whole data structure which I was using. And but definitely I need to check whether this is odd or not. Okay, so the whole thing what I can do is that I can just check that if absolute value of uh, this value, okay, this absolute value module 2 is equal to 1. If it is odd, you just directly return -1. Do not need to do anything. You can just directly return -1. Now you can also check that you can store a count. Okay, so as I was storing a count here, I was checking if they are not equal. But if they are equal here, it will be 0 because an equal number of times incremented here and an equal number of times decremented here, the map will store 0 here. So, but you see, I can directly store count here. Okay, so I can do something like int count is nothing but this value. Okay, and this value count, you just decrement it. This is the extra value which you need. This is the extra thing which you need. And while cnt minus minus, you can just do the same thing. I'm doing the same thing if you just notice. Okay, so that's not the thing. That's not a problem at all. I'm just doing the same thing. So I can just push back in the vector this k. Okay, and I have done it all. You see, I can just copy this vector. I can just copy this vector and I can just comment out this whole thing because this is not required now at all. So what you can do is that you can have this vector here. Okay, now you have a vector. You are storing it in complete optimized way. And what else can you do? Can you change this maps to unordered map? Because unordered map has amortized O of 1 time complexity. Okay, amortized O of 1. Most of the time it will have an amortized O of 1 instead of O of log n time complexity. If you know it already, if you don't know, just know it that using unordered map in most of the cases will be efficient. Okay, so unless you want to iterate the map in a sorted order. Okay, so you just store this unordered map. You just store this unordered map, and you have the vector built. So see, you have the vector built in just one map, and you can do the exact same things again. There will be no problem. If you try to run this and check if it works at all, let's try to see. So you see, we have some issues. We have this F1 and F2, but we now have a single map. Okay, so we do not need two maps, F1 and F2. Just take care of those. You see, we are getting a memory limit exceeded kind of thing, but that should not happen. That should not happen at all. So let's see what is the error in this code. So you get this iteration. You just see that absolute of this. Okay, and you can just do something like absolute of this. Okay, so if count was something like -2. Okay, if count was something like -2, it will keep decrementing count forever. It will never reach 0, and it will keep pushing back this k into the vector, which will cause a memory limit. So I guess that was the error only. So if I try to run it now, will it work? Or we have some more errors in our code? So we got the accepted thing. If we try to submit it and check if our time complexity increases a little bit also, uh, so you see, we are doing actually pretty well here.